Hi students, welcome to Easy BTech channel, and today my topic is about change of order of integration. Before that, please like, share, subscribe Easy BTech channel. Change of order of integration, one of the important topic in multiple integrals. So what is nothing but change of order of integration? So there are two ways to evaluate the double integrations. Okay students, so what are the two ways here? Y limits are as a functions of x, and x limits are as a constants, and next x limits are as a functions of y, and y limits are constants. So these two are about double integration. Then change of order of integration for double integration here. So what are the working rule about the double integration? So at first we are choosing for this function. So that is x is equal to a to b, and y is equal to f1 of x to f2 of x, f of x comma y dy dx. So in this double integration, at first we are doing integration with respect to y here. Which integration, students? This integration. Why here we are doing with respect to y here? Because y limits are as a functions of x. Variable limits are y only. That's why we are doing with respect to y at first and then x. So we are doing first integration with respect to y. That's why we are writing dy at first and then dx. Okay, so this order, so dy dx of the function is nothing but this one is denote as we are doing first integration for y variable and next integration for x variable. So what is nothing but change of order of integration. So if dy by dx is there, students, for some problems for the given intervals or for the given limits, to do the integration becomes very difficult to us for the given intervals, for the given lower limit to upper limit values, or for giving the curves, or for giving the bounded region. So doing the evaluation of the problem becomes very difficult to us. On that situation only we are using this change of order of integration. So how it will be helpful for us? Change of order of integration. See here. So integral of f of x comma y dy dx is nothing but the first doing integration with respect to y and then doing integration with respect to x, dy dx here. Okay, so using this procedure, change of order of integration, so we may change double integration order dy dx order as dx dy. See here. So what is the meaning of dx dy, students, here for the function? So at first integration with respect to x and then second integration with respect to y. That is nothing but the order of integration, means change of order of integration. See here in the second function here, that is integration y is equal to a to b are the constant limits, and x is equal to f1 y to f2 y. So at first here we are doing with respect to x integration and then y integration. So if we are using this change of order of integration, it will becomes as f of x comma y at first dy and then dx. Okay students, then dy means first doing integration with respect to y and then doing integration with respect to x. So when this method is useful for us, students, so for some problems for the given intervals or for the given limits, the doing the integration will be becomes very difficult to us. On that situation we may use this change of order of integration. So what are the working rule about this procedure? So the first one, draw the region. Draw the region means using this limits only we have to draw the region between the curves here. So after that, if these curves and lines intersect, draw straight lines parallel to x-axis. So in the required region, if the lines are intersect to each other, okay students, if in the required region, if the lines and curves are intersect to each other, what you have to do here? Draw straight lines parallel to x-axis only. Okay, so what is the use of this straight line which is parallel to x-axis? Means this will be useful to us as a to get the sub-region. So total one, using the given limits, total region will be existence there. Then after using this intersecting point and straight lines, we are dividing total region as a sub-regions there. Okay students. So the next one, so in each of the sub-region, draw strips which are parallel to x-axis. In the sub-region only we are drawing the strips which is parallel to x-axis to get the limits for x as in terms of y, and then the limits for y as a constants only. So what are the use of strips here? The strips which is parallel to x-axis will be gives the limits of x in terms of y and y in terms of constants only, because the double integration evaluation procedure is this only. So if x limits are as a functions of y, then y limits as a functions of x only. Okay students. Similarly, the order of integration of this function also can be changed. You see here, x is equal to x1 of y to x2 of y. Of this function also changed by using this working rule only. This is nothing but change of order of integration. So now the problem related to this topic. Now here the problem related to change of order of integration. And the problem is change the order of integration and evaluate integral 0 to 1 and integral 0 to root of 1 minus x square y square dy dx. So it was given that here integral 0 to 1 and integral 0 to root of 1 minus x square y square dy dx. So we have to change the order of integration here. Then according to the evaluation procedure of double integration, if the limits are in terms of y here, the first limits are given in terms of y, then these limits are y limits, that means the limits are given in terms of x, then the limits are y limits here, and the next limits are x limits, because if y limits are as a functions of x, then x limits are as a constants only. So it was the order in the question, the order was given that it is dy by dx. So now by using this topic you have to change the order dy by dx as dx by dy. So now using the given limits, y is equal to 0 to y is equal to root of 1 minus x square. Then y is equal to 0 to squaring on both sides, y square is equal to 1 minus x square. Then x square plus y square is equal to 1. That means the circle was given here. Then similarly, using the x limits, x is equal to 0 to x is equal to 1. Okay. So if you are drawing the corresponding diagram, x axis and then y axis. So circle was given here, that means circle is symmetrical about 4 axes. It is a circle equation. X square plus y square is equal to 1 here. Okay. X square plus y square is equal to 1 means the radius is 1 here. That means here on x axis the value of y is 0, minus 1 comma 0 and 1 comma 0. On y axis the value of x is 0, 0 comma minus 1 and 0 comma 1. So observe the question students here. The question, both limits x and y limits are given zeros here. That means the required region is in the first quadrant only. If zeros are there, then required region is in the first quadrant. Then to change the order of integration, we need the strips which is parallel to x axis to get the x limits, and another strip which is parallel to y axis to get the y limits here. Then without drawing the strips we may solve this problem. So like this, see here students, so y limits are given here 0 to root of 1 minus x square, and x limits are given here as 0 to 1. These are the given limits. Okay students. Okay. So according to these limits, y are in terms of x was given here, x as a constant was given here. Then to change the order of integration, we have to change here y as a constant and x as a variable limits. Okay students, have you understood? Y in terms of x and x in terms of constants was given in the question. And now using the order of integration topic, we have to change that x in terms of y, that means x limits as a functions of y and y limits as a functions of constants, or y limits as a constant here. Then for that purpose, what you have to do here, see here, y is 0 is there and 0 to root of 1 minus x square is there na here. Then at first substitute x value in y limits. Okay, x value in y limits. So if your x is equal to 0, if you are substituting here, then the 0 value is 0 because there is no x to do the substitution. And coming to here, substitute 0 in this limit, root of 1 minus x square. If x is 0 here, then root of 1 minus 0, that means 1. Okay, and again substitute 1 because there is no x in the first value, then write down 0. And again substitute the value of x here, that means if x is equal to 1, the value is 0. So what we did here, substitute x limits in y value. Then so in these 4 values, identify the minimum value and maximum value. Minimum value is 0 and maximum value is 1. Then these 0 to 1 becomes as a y limits. 0 to 1. Got it students? Because in it was given limits. These two are given limits. Now we are using here order of integration limits here. So y as a functions of x was given here. Using the order of integration, have to change y as a constant. Okay students. So now we need x limits here. X limits. So as a evaluation of double integration procedure, so now y are constants, then x limits must and should be as a functions of y here. Then for that purpose here, so the first I am writing the given limits, that is y is equal to 0 and y is equal to root of 1 minus x square. Then if you are squaring on both sides, then y square is equal to 1 minus x square. We need x limits, x square is equal to 1 minus y square and x is equal to root of 1 minus y square. This is the one limit. Because x limits are as a functions of y we need here. So one of the limit is x is equal to root of 1 minus y square. So now we need another limit, second limit. Then using the x limits given in the question, x is equal to 0 and x is equal to 1. Because this y is equal to 0 is the y limits, that's why we are not considering this limit, y is equal to 0. So again using x limits only we are finding x limits here. Then x is equal to 0 is one value and x is equal to 1 is another value here. We know that this is one of the limit, that is root of 1 minus y square. So according to these two values 0 and 1, 0 is the minimum value here. Then x limits becomes as 0 to root of 1 minus y square. Okay, now I am writing that limits here, corresponding limits here. By using change of order of integration, change of order of integration, y limits are 0 to 1 and x limits are 0 to root of 1 minus y square. So without strip we are finding limits here. So now we change the order here students. See how I am writing. The first variable limits are x here. X is equal to 0 to root of 1 minus y square and y is equal to 0 to 1. So the given function, integrand function is y square. See here the question consisting the order as dy dx. Okay, so now we changed here x limits as in terms of y here. Then at first you have to write dx at first because variable limits for x here, and then writing dy. This is nothing but change of order of integration. We are changing order of integration here. Then now doing the integration, y is equal to 0 to 1. So y square is common because we are doing integration with respect to x here, and 1 will be there. For 1 the integration is x, 0 to root of 1 minus y square dy. So okay, now doing the integration of this one after substituting the upper limit minus lower limit, students. Okay, now I am substituting limits here. Integral y is equal to 0 to 1 y square root of 1 minus y square dy. Okay, for the integration of this y square into root of 1 minus y square, I am using the substitution method. Put y is equal to sin theta, then dy is equal to cos theta d theta, and changing the limits. So when y is equal to 0, 0 is equal to sin theta, then using this one finding the value of theta as 0. So when y is equal to 1, 1 is equal to sin theta, so the value of theta is nothing but pi by 2. That means theta is equal to sin inverse 1, students. That's why theta value is 0 to pi by 2. So now substituting the limits and the substitution values here, then integral theta is equal to 0 to pi by 2. Y square is there, that means sin square theta, and root of 1 minus y square, that is sin square theta, dy value is cos theta d theta. Then integral 0 to pi by 2 sin square theta. So 1 minus sin square theta is cos square theta. Within the root the value is cos theta, and again 1 cos theta, and again into d theta. Okay, students. So now doing the multiplication of cos theta and into cos theta here, then the value is integral 0 to theta is pi by 2. So sin square theta and again cos square theta d theta. So we know the formula about this one. M and n are even here. Then that formula 0 to pi by 2 formula. That means 1 by 4 and 1 by 2 and again pi by 2. Then final answer is pi by 16. The next question, evaluate integral 0 to infinity integral x to infinity e power minus y by y dy dx by changing order of integration. At first writing the given question. So given integral 0 to infinity integral x to infinity e power minus y by y dy dx. So observe here, students, the first limits are as a functions of x here. That means these limits are y limits and constant limits are x limits here. Then given limits. So what are the given limits? Y is equal to x to y is equal to infinity. X is equal to x to x is equal to infinity. So y is equal to x is a straight line which is passing through the origin. Now drawing the diagram using the given limits, and this is y axis, the straight line which is passing through the origin. So y is equal to x to infinity given here, and x is equal to 0 to infinity. Now this is the required region. Then to change the order of integration here, then we need the strips which are parallel to x-axis, at the same time which are parallel to y-axis also. Okay, to do this procedure which is parallel to y-axis. Then without strips also you may find the limits of this question. Now see here, given limits are x to infinity and x limits 0 to infinity. So now I have to change these limits. So see here, y limits as a functions of x was given in the question and x was constant. Then by using the order of integration have to change x as a functions of y and y as a constant. So it was given that given y as a function of x are constants. So have to change like that, x as a functions of y and y as constant. Have to change of order of integration. Then to change this one, students, so at first I am writing the values here. See here, y x to 10 infinity was given here. Substitute x value here. Okay, then if x is equal to 0, the value is 0, and if x is infinity, then value is infinity. Upper limit to infinity is there, then means there is no x, then writing value of infinity as it is. According to these values, the minimum value is 0 and maximum value is infinity. Then the y limits, according to the evaluation procedure, y limits should be in constants. Then y limits are 0 to infinity. So next we need the x limit as a functions of y here. Then according to the given limits, y is equal to x, y is equal to infinity, x is equal to 0, x is equal to infinity was given here. This is one limit because according to the evaluation of double integration, x should be in function of y here. This is one limit. Then it is not possible to take y limit here because it is y limit. Then by using these two limits, 0 to infinity, 0 is the lower value, that is minimum value. Then x limits as 0 to y only. Now the substituting limits here by change of order of integration. Change of order of integration. I am writing the limits. X limits are 0 to y and y limits are 0 to infinity. Okay. Okay, now I am doing the integration. X limits 0 to y and y limits 0 to infinity. Then e power minus y by y. So at first writing dx and then dy. So why here we are writing dx at first, students? Because x limits are as a functions of y here. So doing the integration, y is equal to 0 to infinity. So here we are doing integration with respect to x here. Then total this y term as a constant, then 1 will be there. For one integration is x here, then x limits are 0 to y and then dy. And okay, and substituting the limits, integral y is equal to 0 to infinity e power minus y by y and into y and again dy. So these both values will be cancelled. So now the remaining term is e power minus y here. So I have to do integration with respect to y here. Okay, students. Yeah, now I am doing the integration here. Then integral y is equal to 0 to infinity e power minus y dy. Then e power minus y integration is e power minus y by minus 1 and the interval says 0 to infinity. So this minus 1 is common, substituting the upper limit at the same time lower limit in the place of y. Upper limit is infinity, lower limit is 0, then minus 1. E power minus infinity value is 0 and e power 0 is 1. So finally the answer of this question is nothing but 1. So thank you, students.